Good morning and welcome back. Today we're going to program from the beginning, including commissioning an Edge 10 controller, Niagara Edge 10. Now it has DHCP. I've put it on my network and it's automatically giving it an address of 192.168.0.18. So I just used advanced scanner to find what the address was. If it's default, it uses 19. If it can't find a network on DHCP, it will use 192.168.10.80. But it's found a network address, so it's used 0.18 here. Now, the Edge 10 can be used for Fanco units, or it can just be used as a small controller. In this case, that's what we're using it for. So let's just bring across the logic, well, the panel drawings. So we've got our power supply 24 volts there, we've got a socket in the panel, normal one of the mill, and that's got a leak detection panel, a water conditioning unit, a cap booster set. What else have we got? We've got two Dix units here, the DM4s, DM41, DM42. So there are your inputs going into your units, and coming out we've got a 0 to 10 volts, so we've got to put that in there. We've got a Wi-Fi router going to go in there for remote connection. They've given a 24 volts DC power supply here for the Ethernet switch. So we've got two Dixes going in, and on the Edge 10 we've got temperature sensors, section 1 and section 2 of the cold water storage tank. Apparently we've got an output for a corridor alarm beacon, lots of spares there, so it looks like we're monitoring CHW and then the DIM 1 and DIM 2 units, which is all to do with detection, leak detection, water conditioner, booster, low level for the tank and high level for the tank. It's really a simple draw, and that's it. So it's not doing a lot, not doing a lot at all. So that should be easy to write. So let's bring across, or let's commission now an Edge 10. Let's start at the beginning, move that across to my other screen so I can look at what's going on there. I'm more interested in the I/O. Right, platform. So this is going to be default Tridium and default Niagara. All lowercase, no capital letters. I'm not going to remember it because I'm going to be putting my own password in there. Sometime today will be fine. Okay, next. Put a passphrase in there. That's my passphrase in. A username. They don't match, do they? Okay. They match now. Go to finish, and then we commission it. I always use the left tree. Yes, I could click on there, but I prefer to just use the left tree. Anyone, well, you choose which method you want yourself. commissioning. So it's at 4.7. I'm commissioning this on 4.8. I always do the controllers on 4.8, and then if it's using 4.13, they will load on there. Wherever I do it 4.13, and then I go to site and I see that we've got a 4.10 controller, then that's a bit of an issue. Next, click on the install the branded Edge 10 4.13 license. Next, yes, you want WB and UX. Don't need the docs. You don't need to send the docs. You don't need to keep the space up on the computer for that. I don't have a station, so I'm just going to go through the configuration without a station. But saying that, I could just load a station on now. Tools, I can't go to that now. No, leave it as it is. Next. You really need a station, and we really should have just made a quick station, because it will only transfer the pallets across that's required for the station. So if you're using logic blocks, it would take across the kit control pallet. Because I'm not using a station, it's not going to be taken across anything. Looking at the drawing, there's no networks here. It's just a DIM, 2 DIM 4 units, Sonte DIM 4 units, and then 2 inputs and 1 output. Well, we certainly don't need graphics for that, but I presume we could put something basic in there, graphic wise. This is just a very, very small controller. Come on, load up. I'm going to just put you on pause then. So, upgrade all out of date. And I'm wondering whether I can actually put in some, let's at least put in the kit control. Kit. Well, I'll use the normal palette for graphics if there is any. And there's no ISMA modules attached to it. There's no point in using any of that. There's no point in using Kit.io. Where are you, Kit Control? Are you actually already been installed? Yep, they're already installing it. Kit Control. So that's fine then. And they're already installing Modbus. Just curious now whether they're installing BACnet. Yeah, it's installing BACnet as well. So all we've added there is the palette for the graphics. There are all your LONs. We don't want any of that. And I don't need any of that for something basic like this. And we don't need weather. Okay, that's fine. I take it back. It has installed the kit control palette. Right. I'm going to again put you on pause, but there's no need. So the link mode is daisy chain, so in and out on the two Ethernet ports. We've got that interface there which is automatically picked up an IP address. I'm going to leave it as it is. And we'll enable the second adapter. Oh no, I can't because it's in and out. So it doesn't make any difference. I would need to change the link mode to enable the second driver to a standard. And looking at this, I think we've only got one connection. Tell you what, I am going to do a standard. Because it's using a router, then I really need a fixed IP address. I don't want it to tell me what address it is. So I'll take that out of there, and I'm just going to use 1.140, which is a basic address for a Jace 8000. And then I'll enable this adapter 10.0.0.125 255.255.255.0. So now I'm in command of the IP addresses and those sockets, so I know what they are. I can connect this to the router. I know it's going to be 140, so I can configure the router for the firewall to look at address 140, and that way there's no way for any issues to be wrong there, anything to be wrong. Let's put the 8.8.8.8 for Google DNS, 8.8.4.4 for the second Google DNS. DNS domain name, let's call it, what is this site? Bourne, B-O-U-R-N-E. No, let's even just take that out completely. Next. Next. Finish. So that's going to go through all these here, and then it's going to reboot. And the new address is going to be 192.168.0.140, which I will then connect to this one on the last job that we did, and I'll just overwrite that name. Saying that, we haven't given it a station yet, so we've still got to give it a station. So we'll let this go through its stuff, reboot, and then I'll show you how we do a station. So I'll put you on pause while it's doing all this. All it's going to do is go through there and reboot itself. So that's finished, this commissioning, and it's rebooting itself. So go to close. We can't use that address anymore now. Go on that address. Platform. Still booting. So I'm just looking at the controller over there. Let's put you on pause again. Right. I've clicked 1.140, which is this one here. I set it to 1.140 and not 0.140 on the IPs. Accept that. Okay. And here we are, 1.140. Let's make a station. Tools. New station. O-U-R-N-E underscore way. I'm not used to space, I've just used an underscore. It's a station. Next. Set password. Okay. finish. So there's my station down there. I'm not going to do anything with it. I'm just going to go into the platform. Again, I like to use the left hand side station copier. Find the station, which is there. Copy it across. Forget that. That's nothing to do with that. I'm not start on the internet, that's all. Next, 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 next. What's to add them items to it? NSS. Finish. Transfer complete. It's rebooting again. It's always better to add the station right at the beginning as you're commissioning. This is taking a bit longer now because I've added the station after I commissioned it, which is my fault. I can't be bothered to stop commissioning, add a station and then commission again. Waiting for this to boot up. So while that's booting up, we need to put a Sante. I'm going to be using a Dix Sante module. I don't know if you know what they are. Let me show you. Let me just put you on pause and let's bring up the page. Right, it is this 4-channel digital input multiplexer. Can we bring up a sheet there? So there's my 24 volts supply and my 0 volts on my out voltage, and we've got in 1, in 2, in 3 and in 4, and depending on the inputs gives you a voltage coming out. So no inputs 0.26, input 4 0.86 volts, input 3 1.45 volts, input 3 and 4 205 volts. So we've got 4 inputs going in, but we're only using 1 input in the controller. So that's why they've used the Dix module on the Edge 10. So we can have 8 inputs, which we've got on the drawings, but we've only got 2 inputs being used because of this module. That's the module that would be in the panel. An ID 04. There's a bit of blurb about it down here. And then there's other stuff there, but this can be current or voltage, and we'll be using voltage. That's the Dix module that we'll be using. Right, we don't want that anymore. We don't want that. And that's that across there. And I want to put my edit. I just need to edit them settings and go back to, because I'm on a different range. Because I set it as an idiot to 192.168.1.140, and I am on 192.168.0 range. So I'm setting my computer back to that range, i.e. not being 140 because that's the unit, so I've set myself just above it so I can connect back into this unit. And just to mess around again, I'm going to just set the THCP range of this unit back to a 0 there and let it reboot itself so that I've still got my internet on. I've used the gateway 0, but when you see here, I decided, and it's force of habit because I always use the default for the JS8000 is 192.168.1.140, but I'll put that back to there, and of course we've still got the 10.0.0.125. So this is going to reboot itself again because I've changed the IP address for Ethernet 0, the primary Ethernet port. So now that's rebooting. I need to set my computer back to normal DHCP, Ethernet, edit that, put it to automatic, save. So that's my computer back to 192.168.0 and whatever address it's decided to pick out. So we don't need that anymore. So we'll close that. We don't need that anymore. So we'll close that. And we will be working on 192.168.0.140 for the rest of this video, which also gives me my internet connection if I need it. Waiting for that to boot itself up. Two temperature sensors, UI1, UI2, tank 1, tank 2, which we've explained. There are two DIMM modules going in there, so that's using up. Put UI2 there, that should be 3, that should be 4, that should be 5. But anyway, doesn't make any difference. The two analog outputs are not being used, and only one digital output's being used to send an alarm across. And the alarm will be any of these storage, cold water storage, go above 21 degrees, I would say. I haven't got any desops, but that's what I'm going to set it to, but I'll make it adjustable. I'll put a little adjustable thing in there so they can change it if need be on the basic graphic. And then leak detection, water conditioning, gas booster, main CHW booster, they're faults, and all them are faults. Low level, high level, low level, high level. So this is just an alarm monitoring panel because everything is to do with alarms only. And it's just going to have some red lights on it. Some white lights for panel is live, 240 volts. Lamp test to check that the lamps are working. There's no reset button, so we don't need to latch anything. Small little panel. That should have booted up by now. With the station in. So 192.168.0.140. So let's accept that. Normal default license. Username and password. And then I'm just going to show you that the station is 4.8. which is what I'm running at the moment, 4.8. So we've got 4.8 there. Edge 10. Nice little controller. Up to 50 points. So you can have up to 50 points. So if you're bringing any meters or whatever via the Modbus network or the BACnet network, we can't do any more than 50 points, which is enough for this job. So let's open up the station. Thinking about it. And then this will change then to Bourne. So accept that. Bourne Way, did I call it? Accept that, okay. Yeah, Bourne Way. So here we have our station now. And our service is an alarm service. So what I normally do there, we can use a default. I don't think we need to do a critical, and because they're all going to be critical. So we'll just use the standard default one. I'll just expose these points. And then I am going to go into my alarm when I can find it. Palette, recipients, and I'm going to do a console recipient, and I'll link that to that. And because they are going to have this remote sending out, I'm going to go a station recipient, which we haven't put a station in yet. And put that into there. I'm just wondering whether I should do an email as well, and actually put an email on this so we can send out the alarm. Why not? We can always delete it, can't we? If we need to. Email recipient. Okay, that's missing, so we need to add that to the station. So software manager. Wait for it to load, and we'll add the email to it. Email. There you are, email. Just select one, but it's going to select the others. Install. Yes, we know you're going to do that. And commit. Doesn't need a reboot. So now we can go back to our alarm service. And now I can get that email, put that email across now. So send it to the supervisor, which is going to be the clouds at my cloud site. It's going to keep it on, store it on the station, and now we're going to email it as well. And I don't know who the email is going to be to at the moment, and we haven't got an email account set up, so we need to set that up. So services, so we need an email account, so let's put the email service from there across to there, and then let's do an outgoing account from there into there, and then we need to set up an outgoing account. We'll be using port 587, and then we need to sort out the host name, the account number, and the password. And I actually don't know what the password is without looking at my notes. So let me just put you on pause and do that. That's the email done. Put the password in there. So that will email out to whatever address we put in there for the alarms. Just put for now. Select outgoing account, save that. You can put language in if you want to, you don't need to. GB. Now we need to put some points in this controller. Oh, before we do that, we'll set the Niagara network up for the server. So new Niagara station. Use secure connection. Right, so that's that bit done. Yes, that's down. Certificate. Okay. Not there. Why aren't you there? Well, I'm on the internet, so that should be on the internet. We'll leave that for a bit, we'll come back to that. But basically what we'll be doing is we're going to certificate management in the platform, going to allow those, and it should be there, the IP address, and it will be yellow, and we will click on it and we'll click on approve. But we'll leave that at the moment. Make a new folder. Logic. So this is where we're going to put everything in there. And looking at that, we've got some universal inputs on that module, which is just temperatures. So we need to do drivers for that. New, and it's not an ISMA. Edge IO network. Okay. Leave it default. It's been ages since I've done an Edge IO. Local. Points. Discover. We want UI1, 2, is it, for the temperatures? Yeah, they're my temperatures. So they are going to be resistance inputs. Resistance input. Why are you doing that to me? UI2. Resistance. UI3. and 4 are going to be voltage. Default. Out of range, may not be connected. Well, yeah, that's right, nothing gets connected. I'm just wondering why it's gone to 11.2. Just bringing it across. No idea. And we've got 1 digital output. So over 2 analogs are not being used, and 1 digital output. Try contact output. And we might as well put the titles in here, because there's no point in making a points folder for just these. I might as well just tidy up that lot there. Pin slots, let's take out in 16. Rename. And that is corridor alarm beacon. Rename. CWS tank. Let's do CWS temperature tank 1. Control key C. Rename. CWS temperature tank 2. Rename. Dix module 1. Rename. Dix module 2. They're going to be degree C. Let's just set it from here. Temperature, degree C. Now that's put it into fault now. Doesn't like doing that. So I'm not going to touch any of them. That shouldn't put anything into fault. Healthy. Alarm. Actions. Set. Healthy. Let's put an alarm point on that. Extensions. Boolean, change of state alarm. And while we're at it, not that we really need to put a history point in, but I'm going to. Boolean, change of value. Let's do the text for the alarm. Leave it a default alarm class. then we'll put in a change of value for the temperature. And we'll go with a tolerance of every 1 degree change. And then we're going to just set that to 5,000. That'll be quite a few. And then roll over. Copy that. Paste it to that. I'm not going to bother with any histories on them points there. So now we need modules, a Dix module. So I don't know whether to write it from scratch or bring one across that I have done before and then talk you through that one. I think I will bring one across and talk you through that one. Put you on pause. So that's it brought across onto here. I'll just link up that one at the moment. Link mark. And that's going to go from that one, link 2, out into belts in. Rename module 1, M1. Duplicate that for M2. Link mark, link 2, out, in. And then these outputs are going to go to, well, we can go to I/O, Boolean writables. Just trying to find it. So leak detection, alarm, click on that, take that. I'll do one here and then I'll just do the others in a bit. Pin slots. So a 1 is going to be an alarm, I would have thought. Healthy. Save that. And then I want to go to my, I might as well put a history on there as well. So a Boolean change of value. We'll leave the name as the same. So it's going to just say leak detection alarm, parent name. We'll leave that all as it is. That would probably be nice to put some, not spaces, but underscores on that one. So that's our history and our, let me put that to 5,000. And then I want the alarm, Boolean change of state alarm, put that in there. We'll leave everything as it is there. We'll just put alarm healthy. We could write it all in, but the title is going to tell you what the issue is there. And because we've got a 1 there, that's the reason why that's an alarm. Duplicate that. The next one is water conditioner fault. Go OK. Take that there, put that into there. But I'm going to put you on pause while I do all the others. There's no point in you seeing what I'm doing there. It's just replication of the other 2. So that's those added. take that down there just to make it look a little bit neater. Now I'm thinking about these here. I think I'm going to put a temperature sensor, physically connect one to this controller so you can see. Should be 10K3A1s. So let me put you on pause and let me just connect the temperature sensor. So I've installed two temperature sensors, outdoor temperature sensors. So that's done for that. We need to put an alarm on these, so if they go above 21 degrees we send an alarm out, and we can also put on there the numeric, oh, we've got that one there, sorry, got one there, paste that one onto there, and then let's do the alarms. So we're going to go for out of value range. We'll do one and then we can just copy it across. So high limit 21. We'll do a dead band of 1, so it's 0.5 either side. Low limit, we can leave low limit at 0. It's never going to be 0, and if it is, that's not good for the incoming water. So above 21 degrees C, below 0 degrees C. Temperature issue, temperature healthy. Save. We can copy that and paste that into there. I don't need to say what tank it is because it's in the title, tank 1 or tank 2. Right, the Dix modules. So this is one that it's probably on previous videos how this was done. I can't think what video it is now, but that's my voltage input, and depending on the voltage input it will give these inputs here of what's been asked for. And I'm just thinking if this is the wrong module. No, it's the right module. So depending on the inputs here, we should put a little table down here. Let's go into, in fact we'll do it in the table I think. So we'll take that, move that across just to test it. We'll put a numeric writable there. Test point. We'll take that out from there. Yeah, okay. Put that into there. Actions set to 0. Pin slots take out in 16. We'll composite that out. Composite. Go down at the bottom. Test. In 10. So in 10 there. Views. AX slot sheet. Control key C. We can get rid of that one. Delete that. Yes. Control key V. Volts in. So volts in. Goes to there. Goes to there. And we'll move that up to the top. reorder, take that and move that up to the top, so it's the same top as that one there. Link mark, I'm going to put it to the physical input on the edge 10, just coming up fault, which is fine, it's still 0 there, all them are off. In fact, that's a good thing to have for all of them, so I'm going to delete that one, duplicate that, link mark, link it to the physical input, universal input, and put these into there, so if it goes faulty we don't have these going into alarm. So that's one that I should really keep there with that. So let's go 0.9 volts, actions, emergency override 0.9. Number 1 outputs on. Let's go for 1.6. Number 2 outputs on. Let's go for 2.2. I'm not going to go through all these, but just give you an example. So that should be 1 and 2. 1 and 2. You get the idea. Let's put that back to auto. 0, all off, all off. So we have a linear reset here. Input low, 0.30, which I've put there, composite it to the out. So you could change it if you wanted to. Same with the input high. So we're going from 0.3 to 10 volts. And then that rescales it from 0 to 15.48, which goes into this modulus block. And there's a 1 there. You want to know what this block does, you can right click it, go view and guided help if you're not too sure. It's come up on my other screen and it hasn't really, there's nothing there, it's not showing it on this version of 4.8, but you'll be okay probably on your versions. So that same output is going into this subtract here, and it's going into this T-stat. And the T-stat is 0.55 differential 0.23. It's actually 0.225, which I wrote there. So that will give us a true signal, and then this one is subtracting one from the other, which will give us a true. Let's put a value in there. Actions, emergency override. Let's put 5.9 volts. It should be 1 and 4. There's your 1 and your 4 output. So that's giving me a value there of 8.9362, taking away the 0.94 into the binary and then adding the 1 there to it, which is gives us a 9. So it's putting a 9 into this numeric bit. Let's mask it on the 1. Let me just show you this a little bit more. So out 1, in 9, and mask 1, and that's your 9. This is a numeric bit again, which is a 9 in there, mask 2, 9 mask 4, 9 mask 8, and they're going into divides, and that's your outputs. That was the simplest way of doing on a Niagara Trillium system the bits for one input and the outputs, unless you know of a simpler way. that's the way that we are using, and I have used on many jobs in the past, and it should be easy for you to copy that logic across. Let me just expand that a little bit for you, so you've got some text there and you can see how it's all, so you should be easy enough to write that for yourself. It's not complicated, and that will give you your outputs on a Dix module. At the moment that output is on 1. Let me take that actions, sorry, 1 and 4, emergency auto. So now all them are back off again. Right, have we actually done it? Have we finished that now? Let me reorder that. Sorry about that. M2 up. Oh no, we've got to send the alarm, haven't we, to the reception. So all of them, and then we've got to put the output. We've got to send it to the output. So we only need an OR gate, or 2 of them. So let's go to our OR gates. Kit control. Logic, OR gates. Pin slots. We'll call that Dix 1 alarms. Alarms Dix 1. That way when I duplicate it, it automatically changes to Dix 2, so I don't have to do any more typing. Put the alarms into there. The same with these. And I think it was called a corridor alarm, so let's just do that there. Corridor alarm. Put that into there. Put that into there. Tidy this up. That will do. Take that. Link market. And we're going to go to the edge controller. Link from. Out. Into there. Do we need to do graphics? I personally don't think so. I think it's just going to be an alarm, and we're going to send that alarm out via email, via our alarm service, and I'm going to send it also to the cloud, and that's for you to view the alarms. Acknowledge. Yeah, that's still an alarm at the moment for the server. And it could be a situation that's something to do with my network here, because it's still not there. But I'm not worried too much about that. That is it. That's that commissioned and set up a small Edge 10 for alarms. Thank you for watching.